Okay, Sarah traveled from point A to B, 0 miles in 0 minutes, and then in 130 minutes reached 100 miles away from her starting point. And as described before, here are the pieces of the piecewise function f1, f2, f3, f4, and f5 correspond to the colors. Now we're going to add a note. And we can do that by adding a note or just putting the quotes right there. And we write Sarah travels the same distance but takes twice as long to view the blue bonnets on the way. So the new function, I can just write the transform function. S of x would equal f of x divided by 2. I'm not going to multiply or add anything to the outside of f of x outside the parentheses, inside the parentheses, because I want to stretch the x twice as far from the y-axis. And you'll see that basically I want to take twice as long. So instead of a 20-minute lunch, instead of taking 20 minutes to drive, it's going to take 40. And so that point will have moved. This instead of being 40 would be now at 80. I said 80. So moving 0 twice as far from 0 is still 0. Moving this point here twice as far, 20 should be at 40. And the 40 now is at 80. The point this was here at so these points are further away than they were before. 130 is now at 260, and 120 90 is now 240 90. From this point 180 used to be at 90 80. This point is now at 80 20 used to be at 40 20, and 40 20 used to be at 20 20. Right there. Okay, that's the new table. Now writing this set of at S1, our new function. So I guess I should change my notation over here, maybe write something like S sub n. Well, I'll leave it be for now. Let's see. So here they are. That's the first piece. Move it up a little so you can see that, and it should be red because that red piece now takes twice as long, reaches the same height. This black piece, blue, takes twice as long and starts later. This is the green piece from before. And again, it's the same height, but it's stretched out piece by piece, farther away. This distance is doubled because I'm further away. So there it is. There's the new road trip for Sarah. She takes twice as long in each piece. So since I'm going to substitute an x that's twice as long to make the y the same as before, I have to undo doubling the x by halving the x. And that's it. Now you could also affect it uh, by actually changing these expressions here and writing out the function. Let's take a moment to see what that would look like. Let me turn off these. And do this here. So I'll change the inputs, but excuse me, I would take the rule and change the x. There's no x to change here, but there is an x to change here. There's one here. And one here. So we should look at that. Here's this, but then gotta do both parts for it to make sense. And this is what the expression should look like. Okay. Now, in the Inspire or other graphing modes, you'd have to solve this for x, which would mean you'd have to double this 80, for example. From this 40 to 80. Multiply this by 2, it gets x. Multiply this by 2, you get 180. So you could read that it happens at minute 80 to 180. Now, that she gets to the third part of her trip at that point, between minute 80 and 180, because it's taking her twice as long. Or you could just leave it like this, and if the graphing calculator allows you, you could see that before it was 120, now it's 240. Before it's 130, now it's minute 260. Okay, but I am going to put it back. We had it like that with these. Yeah, okay.